All right, another week down and a new chapter. We're working on 4.1, 4.2, and 4.3. With chapter 4, we're solving systems of linear equations. So that means more than one equation. All right, here's 4.1. The first half is solving by graphing. Okay, so the first thing we need to do, and this is just a review, is first we need to decide if a solution is an ordered pair. All right, so when we do that, you will get an ordered pair. Okay, and then like I said, this is a review. This is how you check your answer, and then we'll go into graphing. So once you're given your ordered pair, you find your ordered pair, you put it in both equations. So your x is a -3, your y is a 1, you plug it in. And if both statements become true, then you know that the ordered pair is a solution for the equation. However, if you have an ordered pair and you plug it in and one is true and one is false, then that means 4, 2 is not a solution for the system of the two equations, so the two linear equations. We worked on checking your answers previously, so that should be a review. When you are graphing, the first thing you have to do is graph the line. So you can do a t-chart or you can do slope-intercept form. I'm going to start with the first equation. I rearranged it, okay, and I'm going to graph it. So if I rearranged it, I would subtract a 2x from both sides, then divide by a -1. So I'd have a -2x, or excuse me, a +2x minus a 6. And then I just graph and I put multiple points. So you could, depending on which one you picked, you would have multiple answers. My second graph, I look at it. You could do a t-chart or put it in slope-intercept form. I graph. Okay. Now when I'm looking for a solution, I am looking for the point that the two lines intersect or touch each other. So in this case, the lines appear to intersect at +4, +2. So my solution would be 4, 2. If I'm not sure if my graph is perfect, I can take that information and I'll plug it in. So I take 4, true and I plug it in the first equation, and take 4, 2 and plug it in the second equation. Both of them are true, so I know that my solution for the system of linear equalities is 4, 2, and I'm done. Here's another one really quick. I have my two problems. I graph the first one. I graph the second one. Oh my goodness, look what happens. None of them touch. Okay, so the lines appear to be parallel. If you have parallel lines, they will not be a solution. None of them will work because they never intersect. Okay, finally, reversing. So when I check my answer, the easiest way is to put them in both y-intercept form, or slope-intercept form. So when I rearrange, I notice that both lines have a slope of 1/3, and you can see that because I redid them and I put them together. Okay, a slope of 1/3. When you have identical slopes, they are parallel. There is a no solution. So if your lines are parallel, you cannot have a solution. You are finished. Here's another one. It's possible to have your first one graph your second one and they land exactly on top of each other. When they are identical like this, you get an infinite amount of solutions. That means anything can work, okay? Without graphing, okay? So this is 4.2. So graphing is very basic. You just graph your two lines, find where they touch, if they touch at all, or if they touch always, okay? Substitution is another method you can use. When you have two equations, you need to substitute the second equation for the first equation. So the second one already has a variable by itself. It has x by itself. So I'm going to use y + 4, and I'm going to plug it in anywhere I see x in the first equation. So x is right by the 2. I plug it in. 2 times y + 4 + 3 equals 13. Excuse me, a 3y equals 13. I distribute and solve just like normal, and I just keep on going. You guys should be good at solving by this point because we've practiced it a lot. You go down, you subtract 8, you divide by 5, you get y equals 1. Okay, from here, I'm not finished. I only know one variable. I still need to find my second to get an ordered pair. So I'm going to take that 1 from y equals 1 and I'm going to plug it in. So I'm going to look at my two equations and I pick the easiest one. Since x is already by itself, I'm going to plug in y for 1 and I know that x equals 5. So my solution for this ordered pair, without graphing or anything like that, just substituting information through, is 5, 1. Then you check your answer, okay? Here's another one. This one is not so pretty, okay? None of them have a variable by itself, so I have to rearrange. So I'm going to take that first equation, and I'm going to solve for y first. So I'm just rearranging my equation. I subtract 3x on both sides, then I multiply or divide by a -1, and it changes my sign. So now that I know y, I'm going to take that 3x minus 6, and I'm going to plug it in. So I pick an equation, I pick the second one, and I plug in my information. So wherever I see y, I'm going to put in 3x minus 6. I solve just like we've been practicing. So distribute, simplify, add 12 on both sides, divide by a 2. I have x equals a 2. My ordered pair will then be x is 2, y is 0. I can double check. Oh, look, they're both true. So I know the solution for this system is 2, 0. Addition method, okay? So when I use the addition method, your goal is to cancel out either the x's or the y's. In this example, it's pretty. My y's are already opposites. So I have a positive y and a negative y. So I'm going to take this equation and I'm going to cancel out my y's and add straight down. So I look down at my x's and I'm like, ooh, I have 2 x's. So I write 2x. I add 7 and 9, I get 16. You divide, I know x equals 8. I'm not finished here, I still need to solve for y. So because I knew that 8 is a substitute for x, I'm going to go back to one of my equations and I'm going to plug in 8. So I place the x value with 8 in the first equation. I subtract 8 from both sides and I get -1. So my product, or my ordered pair that works for both equations, will be a positive 8, my y value is a -1, and I am finished. Okay, if I wanted to check my information, I would plug it in. So I had 8 and 1. Oh, look, they equal 7. That's true. My second equation was an x minus y equals a 9. I have an 8 minus a -1. Oh, look, it's true. Perfect. I know that's my solution. You do not always have to check, but it's good if you're unsure if your math is correct to do a second look at the equations. Here's one that's not so pretty. So in this case, my x's and my y's do not count. So I'm going to look at the first equation, and I know that if I multiply by 5, but in the second equation and 5 in the first equation and 5 in the second, I can cancel out my y's. Okay, so it becomes 15. So I multiply everything on the left side and the right side of the equal sign. So 5 times 6x is 30x. 5 times a -3y is a -15y. And 5 times a -3 is a -15. I do the same thing multiplying by 3 on the bottom one, and then I can see that my y's cancel out. So I add straight down. I get a 42x, my y's cancel out, equals a -42. I divide by 42, x equals a -1. Okay, so I literally just take my problem and work my way straight down once I can cancel something out. I plug in, so I picked the first equation, my original equation. I plugged in my -1 for x, and I solved for y. So my ordered pair is -1, -1. So that tells me if I was to solve this by graphing, my lines should touch at -1, -1. Okay. Now sometimes it will cancel each other out altogether, and that's a no solution, which we went over in class. If you have any questions, feel free to email me.